So we are going to continue where we left off in the 6-3 investigation video from yesterday. We're going to work on problem 13. Now, for problem 13, the first thing we should notice is that we need to get it into factor form. So x squared plus 3x plus 2 factors to be x plus 2 times the quantity of x plus 1. Once we remove the 2 from this one, we're left with x squared plus 5x plus 6, which then factors again, and this is the final factored form. So factoring done. Now the next step is to look for holes. For the very first time, we will notice that we have an x plus 2 on top and an x plus 2 on the bottom. So where x plus 2 equals 0 or negative 2 would be a hole in our graph, which I'll show you how to deal with in a moment. Now, let's write the simplified form to the right here. So all I've done is remove the x plus 2 factor, so then we can actually look at answering the rest of the problem through that factored reduced form. So our vertical asymptote is where that remaining factor equals 0 or at negative 1. Now, let's go to our graph paper and put on a vertical asymptote at negative 1. Now, what are the zeros of this function? Well, it is where our remaining factors on top are equal to 0. Now, 2 will not equal 0, so don't have to really worry about that. But x plus 3 equals 0 at negative 3. So let's go to our graph paper, and at negative 3, let's put on a 0. Now, what is our horizontal asymptote? Well, on top, we originally had a 2x squared over an x squared, which reduces down to 2. If we look at our reduced form, we have a 2x over x, which reduces down to 2. Guess what? Our horizontal asymptote is at 2. So now let's go over to our paper and put on our horizontal asymptote at 2. Now, for the very first time, we had a hole, and I want to show you how we deal with that removable discontinuity. Our hole occurred at negative 2. So we are going to use this version of our function to find out where the hole is located. If I plug negative 2 into the original, it doesn't work. I get 0 over 0. But if I plug negative 2 into that function, I get 2 times 1 over negative 1, which is negative 2. So then we're going to go over to the graph, and at the point negative 2, negative 2, we are going to put a hole. Okay? But that does tell us that we have a spot in our graph that's in that bottom left corner. So we need to know now, well, what's happening over on this side. So we didn't find our y-intercept, so that's an easy one to plug in. So we could plug in 0. If you plug in 0, you get 6 over 1 or 6. So we can plug that in. Let's plug in 1. If we plug in 1, we get 8 over 2 or 4. So this piece is locked in this corner. So that is how we graph a function with a hole, a removable discontinuity. Now, I want to do one more together, and then you have the remainder of class to finish this yourself, okay? So let me cut and paste one of these. We're going to do 10 together. Okay. So the first thing we have to do is we have to get this into factored form. If you removed an x, you'd be left with x squared minus 16. Now that reduces or factors one more time. So our final factorization is x plus 4 and x minus 4 times x. Now, if we remove a negative 4 from that bottom, we are left with x squared minus x minus 6. So keep in mind that x squared minus x minus 6 would reduce again. So x squared minus x minus 6 would be x minus 3 and x plus 2. Now, we did get it in factored form. It just so happens that no factors on top and bottom match, so there are none. There is a vertical asymptote where x minus 3 equals 0 and where x, sorry, I got ahead of myself there, where x plus 2 equals 0, so at positive 3 and negative 2. Stop what we're doing, go over to our graph paper, put a vertical asymptote at 3 and at negative 2. What are the zeros? Well, that is where the factors on top equal 0. So 0, negative 4, and positive 4. So we hit 0, negative 4, and positive 4. Because the top has a power of that is exactly one more than the bottom, we have no horizontal asymptotes. What we will have a slant. So how do we do that? Well, we're going to divide this into this. Okay, now I had to put some zeros there to make that division work. So what times negative 4x squared would get a positive x cubed? Well, we need an extra x, and we need a negative 1/4. So that would be negative 1/4 x times negative 4x squared is positive x cubed. Negative 1/4 x times 4x is negative x squared. Negative 1/4 x times 24 is negative 4x. But we are subtracting, so change the signs of all of those. And we get x squared minus 20x plus 0. Now, we got to do it one more time because we've got to get to that constant spot. But it's okay. Let's do negative 1/4. And then we don't have to go further as long as we get the right number there. So how do we graph that? Well, we start at negative 1/4. We go down 1/4. And we could also go up 1/4. And let's draw our slant asymptote. Okay. So we're definitely going to need a few points here. First, let's look at this region. Let's plug in negative 3. If you plug in negative 3, you get 21 on top. I kind of do top and bottom separate. And then if I plug negative 3 in the bottom, I get negative 24. 21 divided by negative 24 is approximately, well, it's actually equal to, well, let's round it, negative 0.9. So when I plugged in negative 3, I got just before negative 1. So we're following that asymptote here. Now the middle doesn't have to follow anything, so it might just do its own thing. So let's do the right side first. So let's plug in 5. If I plug 5 into the top, I get 45. If I plug 5 into the bottom, I get negative 56. And then that's really close to negative 0.8. So see how these two pieces do follow the asymptotes. The only thing, the middle can kind of always do it at once. So I don't know, I need something over here. So does it go up or does it go down or what's it do? Okay. So let's plug in -1 and +1. If I plug in -1, I get 15 in my numerator and 16 in my denominator. So just under 1. If I plug in +1, I get negative 15 in my numerator and 24 in my denominator. So just before -1, and I think that it would be right there. So I actually think we know the only zeros are at 0, -4, and 4. So this piece goes up. This piece has to keep going down because it can't, if it flips back around, you'd get an extra 0 that we don't have. So like I said, the middle can kind of do what I want. Sometimes I will not put any part of the horizontal, vertical, or slant asymptotes in the center. I will only just, kind of keep the horizontal or slant asymptote on the ends so that I know that's what the end behavior is doing. So you have the remainder of the period to be working on these. So there you go.